In this video, we're going to talk about imaginary numbers. So the first question asks us to grab a calculator, or you can go to the Desmos Scientific Calculator. What happens when you try to calculate the square root of -4? So you may have seen this before, but if not, we're going to demonstrate. The Desmos graphing calculator is found here. There's also a scientific calculator at desmos.com. You can select it in this area here or click on Math Tools. And this is what the scientific calculator looks like. So if I want to calculate square root of -4, what happens? This calculator says undefined. So various calculators will give you various different types of error messages, but it will give you some sort of error, undefined message that tells you that it can't do it. It's not going to give you a nice number answer. So this was undefined, and the reason for that is because there is no number that when you multiply it by itself, it will equal -4. We know that if we multiply a negative number times a negative number, it's going to be a positive number. Positive times positive is also positive. The only way to multiply two numbers and get a negative is if one is positive and one is negative. And if that's the case, then they aren't the same number. So a little bit of historical background here. Early civilizations began with counting numbers. 1, 2, 3. People have been counting for a very long time to keep track of things. But the number 0 wasn't used until much later, and negative numbers weren't accepted until late in the 16th century. So we don't really think very much about numbers as something that has been invented. We kind of just assume that they have always been there, but that's not really the case. For much of human history, negative numbers were not a thing, and they were invented to allow us to deal with situations like debt. So if somebody has spent more money than they have a negative amount of money, and we needed a way to represent that. So that's when negative numbers came about. So another type of number was invented called imaginary numbers to help us solve equations like x squared equals -4. So we know that there is no number that when you multiply it by itself, it equals -4. But we wanted a way to still be able to do some math with these sorts of things. So that's why imaginary numbers came about. The imaginary unit I is defined as the square root of -1. So this I stands for the square root of -1, and I squared then equals -1. So again, it's not a number because there is no number that when you square it, it equals -1. But it's an imaginary unit that allows us to still do some math with these things. So if I had square root of -4, what's going to happen is that I separate the -4 into -1 times 4. The -1 becomes the I that I can then represent on the outside of the square root sign. The 4, positive 4, can stay under the square root sign, and since it's a perfect square, I can take the square root of it and get 2. So when we look at the position of the I here, if it's just with a number like this 2i, then we treat it mostly like any other variable where we would write the number first and then the I would come second. If we're dealing with the square root, then we generally write the I in front of the square root. And the reason for that is just because it makes it easier to see that the I is not meant to be under the square root sign itself. It's meant to be on the outside, and it's a little bit harder to see with this overhang of the square root where the square root ends. It's easier just to write it in front of the square root sign. So let's look at some examples here. We have the square root of -81. So I can do the same process that I did up here in this example. Square root of -81 is the square root of -1 times positive 81, which is I. See, that overhang is a little bit tricky to deal with the square roots, especially when you're handwriting, which is equal to I times the square root of 81 with the I in front. And I know that the square root of 81 is 9, so this is 9i. Now, you don't have to write this out with all these steps. This is excruciating detail here. You can probably just go right from this to this just by thinking about the answer. Now with b, we see we have a negative sign in front of the square root sign. And you might be tempted to combine these two negative signs and just make it positive. But we can't combine that way because one is outside the square root and one is inside the square root. So what's going to happen here is I'm just going to put a negative sign in front of everything. I know that I'll write this out in the detail again. I'm breaking negative 49 into negative 1 times positive 49. And then I'm going to have negative I times the square root of 49, which is 7. So this is negative 7i. So you have to keep track of these negative signs. They are two different things. The negative sign on the outside is just going to stay on the outside and go in front of my answer here, whereas this negative sign becomes the I. The one that's under the radical becomes the I. So make sure that you're not losing this sign on the outside. It does not go away when we bring out the one from the inside to make the I. It's still there. Looking at C, we have square root of negative 6. So in this case, 6 is not a perfect square, so I'm just going to leave that as I times square root of 6. 6 can't be simplified, so nothing to do with that. That's just the answer. Now for this one, square root of negative 54, there is a little bit more to do, because I know 54 is 9 times 6. So 54, that can be simplified. So what I can do here is a couple of things. I know that the square root of 9 is 3. The negative sign here is also going to become the I on the outside of the square root. What's left under the square root is a 6. This 6 right here. So this square root of negative 9 becomes 3i, because square root of 9 is 3, minus sign becomes I, and then square root of 6 stays that way. So if I wanted to kind of draw some arrows here, negative sign becomes the I, 9 becomes the 3, 6 stays under the square root.